3.2.3 Solve systems with matrices. It sets your question. What information does each element in the augmented matrix provide about the system of equations? Skills. I can write a system as an augmented matrix, and I can solve systems using matrices. Write the following system of equations as an augmented matrix. Then solve for x, y, z. When you put them into an augmented matrix, you need to make sure that it is in this form. We have x plus y plus z equals a constant. Inside of the augmented matrix, you put whatever the coefficient is. You need to also make sure they're in the correct order. There should be x, y, and z in that specific order on this side of the equation, and then the other side of the equation should only have a constant number. On the first one, we have 3x plus 4y plus 1z equals 8. It's all in the correct order. There's 1z, so we'll just put a little 1 there. And then let's go ahead and put those coefficients in the boxes. The next one, we have 2y minus 1z equals negative 2. It's missing x, so let's put a 0x in the front. And then we'll put those coefficients in the cells. 0, 2, negative 1, and then negative 2. The third equation, 6z equals 9 plus 5x. The 5x is on the wrong side of the equation, so we need to subtract that over. Also, there's no y, so let's put 0y in between those terms. And then now let's put those into the cells in the matrix. Negative 5, 0, 6, and 9. From here, we will put this into a matrix calculator. Go to desmos.com/matrix. So we go to the site, and let's go ahead and click on New Matrix. This matrix A will represent the augmented matrix we just wrote on our paper. It has 3 equations, so that means it has 3 rows. And then it has 4 different terms, so that's 4 columns. So rows represents the equations, and columns represent the terms. And then from there, we'll just type in those numbers. And press enter. Now, to get this into the solution format, you want to click this button called RREF. It stands for Reduced Row Echelon Form. They called this matrix A, so we're going to put just A in there instead of the whole matrix again. Here are your solutions. This basically means 1x equals 15 over 11, 1y equals 7 over 22, and 1z equals 29 over 11. So those would be your answers. Now, if we ever end up with something like this, with all zeros in the last row, this would be infinite solutions. And then if you ever get a case where you have a number for x, a number for y, and then z gives you a 0 equals 1, this would be no solution. They're both considered dependent. Infinite solutions would be consistent, and no solution would be considered inconsistent. One unique solution, like the one we got here, is independent and consistent. Consistent means at least one solution, and independent means there's one unique solution there. Go ahead and try the other questions on your own. Set up the augmented matrices and then plug them into the calculator, finding the reduced row echelon form of them.